So creational patterns are the patterns that are concerned with object instantiation or object creation. So there are these set of creational patterns, and the primary creational pattern is a factory pattern. Now, factory pattern could have factory pattern. There are in fact three different kinds of factory patterns: simple factory, I should say simple factory, and the factory method. Yeah, it looks like this is not right. Factory method pattern, and then abstract factory pattern, and singleton pattern, and builder pattern, and prototype pattern, and object pool pattern. So these are all examples of creational patterns which are concerned with object instantiation. Okay, so let's take a look at factory patterns. So as I said, there are three different kinds of factory patterns. A simple factory, which is not really a design pattern. It's basically simple encapsulation of object creation into another class. So it's not really a design pattern, but it is still useful. Now, from design pattern perspective, there are two design patterns related to factory pattern. One is called the factory method pattern. Some people call factory pattern, and when you hear someone says factory pattern, they're typically talking about factory method pattern. Okay? So I'm going to use the term factory method pattern. So in factory method pattern, there is in fact the abstract class, which contains the abstract method for object creation. Okay? So there is in fact the abstract method in abstract class, and this abstract factory method of that abstract class is gonna be implemented by concrete factory subclasses, and these subclasses are responsible for object creation. Okay, and then the last one is the abstract factory pattern. It provides a way to encapsulate the group of individual factories that have a common theme without specifying their concrete classes, blah, blah, blah. Okay, now you probably got confused, okay? All right, so let's actually talk about each of these in a bit more detail, and we are gonna do the lab, a lot of lab for each of this. So let's talk about simple factory first. Hold a second, let's resume. So simple factory, as I said, this is not really a design pattern, rather it is a simple encapsulation of object creation into another class. So when to use it? When you need to decouple object creation code from business logic code. You do not want to mix up business logic code with object creation. And when object creation logic changes often, and that's in fact one reason why you want to encapsulate what varies or what changes. That is one of the design principles we talked about, right? Okay. Also, when object creation logic needs to be reused in other parts of the application. So in many cases, a single application might in fact have the need to create an object in different part of the application. So by encapsulating into a simple factory class, you're basically reusing the code. Okay? Okay. So this simple factory is probably the simplest in all design patterns. We're going to take a look. Okay, so again, you are going to download hands-on zip file. So I have that. Okay, so I have. Let me just go to the labs directory. So I am going to unzip. Again, you can use any unzip utility of your choice. I'm using jar command, and that's VF, and it will again contains samples, Maven directory, and homework Maven directory. Okay. All right, so here let you go to dp create. You can see there are samples Maven directory and then homeworks Maven directory. Okay, so you might want to import the class. So I have a Java working set dp creation. So I'm gonna import into it. So import existing Maven project. So expand Maven and select the existing Maven project. And I'm going to select the labs directory here and dp creation. So I'm going to import both homework and the sample made in all of those. Okay. Okay. Finish. Okay, so I should actually have homework in other working set, but that's fine. Okay, so yeah, so there are in fact several simple factories. So you can see I named it in a way that this is the creational design pattern, and then the next string specifies what pattern you're talking about. So if you go to simple factory, you can see simple factory toy after, toy before, and then factory 2 and after, and then we have the homework. Okay. All right, so let's take a look at the first one. So in this case, we are trying to create a toy. So if you take a look at this code, so this is the same code that you have seen before in the encapsulate what changes. So if you take a look at the client code here, we have this business logic. Okay? Business logic of object creation is mixed up with a business logic. So what we want to do is we want to encapsulate this guy into another class. Okay, so this is basically the same example we have seen before. So I'm going to just show you what has been. So in this case, we have a simple factory class. Okay. Which captures object creation, and then client code is basically using this simple factory, and this is the static method, and so this this business logic doesn't need to be changed whenever we are introducing new toy. Okay, so that is the factory 1 after. Okay, so I mean you should be able to all running. And the Java application, and then it should work fine. Okay, all right. The next one is simple factory 2 toy after. In this case, we have another intermediate object. That's all. So here we have a before. So in this example, we have what is called toy manufacturer class. So toy manufacturer class, it does have handle toy order. So this manufacturer will receive an order of the toy through this handle toy order, and so it will create a toy, and then it does have to perform other set of business logic. It has to prepare, then it has to label it, and then it has to ship it. Okay, and then client code is basically create the toy manufacturer, and then it just calls the handle toy order with a toy to create type, either car or a train. Okay, so this is before we use the simple factory. So if you take a look at the after, then we are using simple factory here again. So here, if you take a look at the toy manufacturer here, it's again using simple factory, and it does call create toy. And so here we have simple toy factory to be injected as an argument. So this is an example of dependency injection, right? So when I need to test unit test of toy manufacturer, I can actually pass the mock object of simple toy factory if I want to. Okay. Okay, this is the toy after 2 example. Okay, so you can take a look at this code, and then there is a homework. Okay, so we are going to do the homework of simple factory 1 and simple factory 2. So in this case, expand the project, and the homework that you are supposed to do is explain in client.java file. So if you take a look at the client.java file, okay, so this is the code that does not use design pattern. Okay, so this is your homework, the to-do homework. Create simple shape factory class through which you can create either circle or rectangle, and then you want to compute the area for the created object. Okay, so step to follow. So I provided skeleton code. Okay, so basically I provide rectangle, and which contains height and width, and I provide the circle class, and I provide a shape shape abstract class that contains a compute area. Okay, so you basically need to do so on comment client code below. So so I provided. I have a working version of all this homework. So basically, I provided client code so that you can just kind of add code to make things work. So you basically uncomment this guy, and there will be in fact the compile error. So obviously we do not have simple shape factory class, right? So that's the one that you want to create. Okay, so you can certainly use Eclipse quick tip. Okay. And basically create the simple shape factory in which you are going to create the shape of your choice, circle or rectangle. Okay, so that is the exercise. Homework. Simple factory 1 shape. So that is, if you take a look at the this simple toy factory after, you can actually see the similarity, right? And the next one is homework is simple factory 2 shape homework. So again, here we are introducing, so this is the same code, but if you take a look at the client code again here, I explained that we like to actually have a shape manufacturer class as an intermediary class. Okay, so by the way, when you actually run the final application, the things I expect to be, seeing is like this. Okay, so compute area code, color shape, label shape, and label shape. So in this case, if you take a look at the shape manufacturer, it might in fact have the order. So if you take a look at the, so let's just uncomment this client code. Okay, so this shape manufacturer will receive a simple shape factory object class. So we need to create that, right? And then we also need to have the method that actually handles some of the operations of coloring it, labeling it, and draw it. Okay, so the first thing you want to do is uncomment this client code, okay, and then you're going to add classes to make it work. Okay, so that those are the homeworks. So I'm going to give you guys to do this homework of simple factory, and now we have 12:16. So I'm going to give you guys about 14 minutes to do this homework, and let's have 30 minutes lunchtime. So we will be back at 1 o'clock. Next pattern is factory method pattern, or some people call it just factory pattern. So factory method pattern, you are going to have an abstract class in which it will have an abstract method for object creation, and that is called the factory method. Okay? And this abstract factory method will be implemented by factory subclasses, and these factory subclasses are going to be responsible for object creation. Now, this factory subclass can be chosen at runtime. So if you see description of factory method pattern, you might actually see this description: factory method lets a class defer instantiation to subclasses. So basically what this statement means is that factory subclass will be selected at runtime, and that factory subclass will be responsible for object creation. So when do you want to use factory method pattern? When you don't know ahead of the time which factory class object you are going to, which class object you are going to create. So you are going to choose a particular factory subclass which contains a particular factory method implementation during runtime. Okay? So it will be determined, the object that gets created will be determined during runtime by choosing a concrete factory subclass. Okay? I might actually get back to this description after we do the lab. Basically just listening to what I said on this slide might be a little bit confusing. So once you see the example code, you'll have a much better idea. Participants. So in our description, we are going to have what is it and when to use it, and then we are going to have a slide for participants. The reason I include this slide is because when you try to describe a particular pattern to someone else, you might want to in fact use these terminologies so that a common terminology could be in fact useful to communicate what you're trying to achieve in terms of design pattern. Okay, so it does contain abstract product factory. So this is the abstract class. It contains the abstract factory method. Okay, so let me actually show you examples one by one, and then I'm actually so I'm gonna actually try factory method after. So here, let's say we have I'm gonna actually use the general after. By the way, whenever you see general, that means I'm actually using these generic terms. Okay, so here we have abstract product factory class, and you can see it does have an abstract method called the create product. So this is the abstract method that will be implemented by concrete factory subclasses which extend this abstract class. Okay, so this abstract product class contains this abstract method, and in this case, let's say I have concrete product factory A. This is a class, concrete class, that extends this abstract product factory class, and it provides the concrete implementation of this create product method. So here is actually creating a concrete object. Okay, you might in fact have another subclass implementing this abstract product factory, and here is creating concrete product B. So if you take a look at abstract factory pattern examples, you are going to see abstract product factory class that contains this abstract method, and then you have a set of concrete the factory classes that implement this abstract method. Okay? And the selection of this concrete product will be done if you take a look at the client class. You know, in this case, I'm basically selecting a concrete product, a concrete factory class A. But again, you know, this could be selected during runtime through command line argument. Okay, so in this case, I'm not actually using that. For instance, I mean, the thing that actually shows you for creating a new instance from a command line argument, but you know, to kind of show it in a simple way. But you know, this selection could be done during runtime. Okay. All right. So now we have concrete product factory class that implement this abstract method. Then we have a product, and we have a concrete product. So product is, you can think of as an interface, what type of product. And then we have a concrete product, which is the implementation of this product. And then we have a client, and client will use interfaces declared in abstract product factory interface and product. Okay, okay, so let's do the lab, and again, the lab will give you a lot better idea in terms of how this factory pattern works. Okay, so as I said, let me just show you the factory pattern. Yeah, this is what I described. So we have this abstract product factory that contains this abstract method. Okay, and then we have a concrete factory classes. So you could have many concrete factory classes that implement the abstract method of this abstract product factory, depending on what kind of product each of these factory class is going to create. So if in this case, it's going to create concrete product A, and this factory class will create the concrete product B. Now, again, the product should be abstracted, so we call I product. So I product is interface. Okay, that contains prepare, label, and ship. And then we have a concrete product A that actually provides the actual implementation of those methods of this abstract product. Okay, so if you take a look at the client code, you know, here I am using a particular factory class, in this case concrete product factory A, and then I'm going to then I'm going to call so I'm going to call the normal method and actually get the product, and then I should be able to do anything I want. Okay, now in this case, I'm choosing a different factory class. So in this case, I'm choosing product factory B, and then I should be able to actually call a method. Okay. Okay, so my apology. Let me just okay, sorry about that. Okay, so that is the general case. By the way, when you actually install the object, by the way, if you take a look at the lab documentation, let's take a look at the lab documentation first. Okay, so I'm going to actually read a lab documentation, and there are a couple of steps I want you to follow first. A couple of plugins I want you to install. So here, exercise 0 is, I want you to install Object 8 and Infinitest Eclipse plugins. Okay, Object 8 is Eclipse plugin which you can use to display, to create the class diagram. Okay, if you want to create a different set of diagrams, such as the sequence diagram, you have to pay for it. But for creating a class diagram, you could actually use it. So in order to install it, click this here, and basically you are going to provide this location, add repository. Okay, so basically what you're going to do is select help install new software. Okay, so help install new software. And then you are going to specify, if you click add, then you're going to add this guy, okay, and then you should be able to select this guy and then install it. Next, in my case it's already installed, so I'm going to actually cancel. So Object 8 is actually useful to display the class diagram. Okay, let's see. Yeah, looks like it's downloading something. Yeah, so I want to actually cancel it. Okay, so I want to cancel it because I have already installed it. So all right, so let me actually go back to the lab documentation. That is Object 8. And also Infinitest. Infinitest, you can actually find it from Marketplace. In this code camp, I'm not actually focusing on a testing. So instead of actually writing testing code, we're actually using client code that contains a main method. But in general, you should actually have testing as part of your code development. So Infinitest is pretty useful. So whenever you make a change, and save the change, and it will run the testing program for you automatically. So in my case, once I install it, okay, so I'm gonna just cancel this guy. Okay, good. So whenever I make a change, it will let me know whether the test succeeded or not. Okay, so I'm gonna demonstrate this sometime later on. But for now, I want you to actually make sure that you install the Object 8. So let me show you Object 8. So this is the one that I've created already. So let me just expand Control M, and so I have abstract product factory, okay, which is extended by concrete product factory A and concrete product factory B, and then we have an I product, okay, and you can see abstract product factory should have a reference to I product, okay, and this I product will be implemented by concrete product A and concrete product B, okay. So let me actually create this guy using Object 8. This is what gets created, but let me just remove this guy and let me show you how Object 8 works. So I'm going to just delete this guy. I'm going to delete. Okay. And so in order to use Object 8, meaning in order to create the UML class diagram, you choose whatever directory of your choice and select New. Okay. And then you are going to select Other, and then you should actually see Object 8 UML diagram. Okay, so class diagram is free, so you select New, and I'm going to just name it as UML class diagram, something like that, and finish. Okay, so now I should be able to drag and drop things. So, I'm going to drag abstract product factory, okay, all right, and then I am going to move concrete product factory here. So you can see the relationship between abstract product factory and the concrete product factory is recognized by the tool, and it actually draws things correctly. And I have another concrete factory like this, and then I have I product here, and then I have concrete product A and concrete product B, okay, something like this. All right. Oh, so this is a tool that you can use to draw UML diagram by dragging and dropping, and it's pretty useful. Okay, so this is general. So let's actually take a look at the actual code. So let's see here. Oh, this is the so I have a factory method toy before and after. So if you take a look at the before factory method is being used, okay. So this is the case. Toy factory with no abstraction. So this is not using factory method pattern. So here we have create factory method. So this is kind of encapsulation into a method in the same class. Okay. So this is a simple factory which encapsulate the object creation logic. However, every time new toy class need to be supported. For example, I want to introduce airplane toy. Okay. This code needs to be changed, which violates the open-close design principle. Okay, so here, if you take a look at the client code, it's using this toy factory no abstraction method, and then it's going to call handle toy order, and then object gets created. Okay, so again, if you take a look at this code, this needs to be changed when we introduce another toy. Okay? So we are going to correct this problem by introducing factory method pattern. Okay? So that is the after case. So here we have after case. So here we introduce toy factory abstraction. So you can see this is an abstract class, and creation of a toy will be captured as an abstract method. So like a create toy, and of course you want to create abstract type of toy, in this case I toy. Okay, so this abstract factory class will be implemented by car toy factory class. Okay, so car toy factory class will create, in this case, car toy. Right, and then for train toy, again, train toy factory class extends toy factory abstraction class, and is providing its own create toy method implementation. Okay, so by leveraging factory pattern, so if you take a look at now the client class, okay, client class, basically we select a particular factory class. In this case, I choose car toy factory. So again, you could actually use this logic. So this is the logic that we actually use in command line argument to select a particular toy class. Okay, but instead of actually doing this code, I actually simplify the code. So just assume that I should be able to select particular toy factory class during runtime, and then I should be able to call handle toy order, in which the car toy object gets created. And here I selected the train toy factory during runtime, and then it will create the train toy, right? So if I run this guy, so let me just run this application, and it will create train, prepare train, label train, and ship train. Okay. Oh, so it's actually creating a car first, right? Okay, it's creating car, and then it's going to create the train toy. Okay, so instead of actually doing this, you could actually do this way, and this is again example of select. So this one should be commented out. So this is a way of selecting a particular factory class during runtime. Okay, so in this case, we are basically choosing a particular factory class, okay, as a command line argument. So here I'm actually using car toy factory as a default, but you should be able to pass either DP car toy factory or DP train toy factory or DP plane toy factory class, and this code should work without a change. Okay, so again, this is providing open-close principle for creating an object, if you think about it. Okay, so you can certainly actually create another toy factory class. So here I can actually create another toy, like I'm gonna say a plain toy. Okay, so I'm gonna create the plain toy factory. So whatever concrete object type you want to create, you basically create a new factory class. Okay. So here I'm going to just copy. So here I'm going to create a plain toy. So here I have plain toy factory here. So here, and I'm going to create a plain toy. And of course, I don't have a plain toy, so I have to create the plain toy class. Why it doesn't actually give me control? Create plain toy, and so here I can actually provide plain toy. So I'm gonna just maybe just use this guy and plain toy prepared. I'm gonna just copy this guy. This one is labeled. This one is labeled. And this one is shipped. Okay, so basically each toy should have its own implementation of this iToy, the abstraction. And in terms of client, now I should be able to choose a particular toy factory class during runtime. So for the sake of this demo, I'm gonna just use maybe plain toy, okay, and save all the changes. Now if I run it, so what is the other? Okay, plain toy factory, plain toy. So here I say the method create toy type of plain toy factory must override implementing super type. Oh yeah, I didn't actually extend. Yeah, so I didn't actually extend the abstraction. Okay, so I'm gonna just copy this abstraction and add here. Okay, and save the change. Now Control F11, and it's actually creating a plain toy for me. Okay, so now the key point I want you to focus is, I was able to create plain toy factory and the plain toy, by introducing plain toy factory concrete class, and I didn't have to change any existing code at all. And of course, I changed the client code, but this is just for the demo purpose. This plain toy factory could be actually received as an argument, right? Okay, so I was able to actually add the functionality without changing existing code. So I was able to follow the open-close principle. Okay, so that is the factory method 1. Now factory method, let's see, what is the factory method 2? Okay, so I'm going to actually show you factory method 3 and before. So this is the what is the factory method 2? I should have a factory method 2. Let me just okay, so let me just try to import the factory method 2 here. Creation. Looks like I have a factory method 2 already imported or something. to this guy. Just import the. It's possible that I messed up with the name of the project. Okay, so let me see here. Method 2. Okay, so this is the one I was looking for. Okay, yeah, so I have those projects. Samples in even, that's what I meant. Okay, so I'm looking for not homework, but okay, here it goes. Samples factory 2. Oh, it's interesting. Okay, all right. So somehow I couldn't find the factory method 2 toy after example. Okay. So let me actually show the third one. So this one is the case. So in this case, I am actually creating the toy created at the different state. Okay. So if you take a look at toy factory with no abstraction, okay. Now the difference is actually per state. Okay. So the for New York State manufacturer of the toy will actually create differently. So it will create a New York car toy and New York train toy. And for California, it will create a California version of car toy and train toy. Okay? So this is, in this case, we have a create toy concrete method. Okay? And we like to, now if you want to actually create a toy in Chicago, then we have to change this code, right? Okay? So what we want to do is we want to use a factory method pattern. So we are going to create, so I'm going to actually take a look at the factory method 3 toy after. So if you take a look at this guy, now we have toy factory abstraction class. So in this case, we have abstract method. Toy abstract class is created by trade toy. And this is the one that will be implemented. In this case, we are going to create different factory classes per state. So we have California toy factory class that create toy method. And then we have New York toy factory. So New York toy factory implement toy factory abstraction class, and is providing the implementation of create toy, and it will create a New York version of those. Okay? So if I want to create a Chicago toys, like a Chicago car toy and Chicago train toy, and then I should be able to just create a Chicago toy factory class, extending toy factory abstraction, and then I should be able to proceed. Okay. All right. So those are the sample applications. Now I want you to do the homework. Okay. So homework is the factory method shape homework. So I want you to spend some time, looking at example code and get some understanding of how factory method pattern works. Now you want to do homework. So homework is again specified in client.java file. So I want you to create a circle and rectangle using factory method pattern. Okay. So here you can just uncomment. Yeah. So this is an option. Decide which concrete factory to use. You can just uncomment this guy. And this is the option 2 is actually again receiving a factory class name as an argument. Okay, so you can actually use either option here. So I'm gonna just use this guy. Okay, and you can see you need to create the abstract factory abstraction class. Okay, and you also need to create the rectangle factory, and you also need to create a circle factory. Okay, so basically you are going to create these factory classes. Okay. Which implement this create shape abstract method. That abstract method is something that you have to include in shape abstract factory class. Okay. Again, I provide the circle, shape, and rectangle, and the client code. Okay. So in this homework, you basically need to create this abstract factory class and concrete factory class. Does that make sense? Okay. Okay, so I am going to give you guys about 30 minutes to do this factory method exercise. Again, try to understand the sample code and then do the homework. Okay. So let's go over the factory pattern one more time. Now you have done the lab exercises, you have some exposure to the code. This might actually give you a bit more clear idea. Factory method pattern. It defines an abstract method called the factory method in the abstract class. And then there will be a set of factory subclasses which implement that factory method, factory abstract method. And factory subclass will be selected during runtime based on business logic. Then that factory subclass will be used to create a particular product. Okay? So you want to use a factory method pattern when you don't know ahead of the time which class object you need to create. And that will be determined by the selection of a particular factory subclass during runtime. Okay? Again, by using factory method pattern, you are following open-close principle regarding object creation. So when you need to create brand new type of an object, you don't have to change the existing code. Instead, you are going to create new factory class and then new product type. And that's pretty much all needed to do to support the new object type creation. In terms of participant, so abstract product factory, that is the class that contains the abstract method. And concrete product factory classes, so these are the subclasses that contains the implementation of this abstract factory method, okay? The factory method. And then we have a product which represents a product in abstract way. Then we have a concrete product, and then we have a client that actually use those classes. Any questions on factory method pattern? So in terms of the open-close principles, so this is the result of homework. So basically, I need to create a shape factory abstraction class, and this one has handle to order method, in which is going to call this create shape abstract method to create a shape type of object. Then you should be able to perform some business logic, compute area, label it, and draw it. Okay, and then we have concrete subclass of this guy depending on which shape of object that you want to create. So we have circle factory class that extends this shape factory abstraction class, and here it provides the create shape method implementation. Here is creating a circle. Same thing for rectangle, right? So if I want to support the creation of triangle, basically all you have to do is create new, and you might want to say, try to create the triangle class first. And triangle class is basically, some implementation of its own of compute area. So I am going to add compute area here, and it will be, it will probably have the width and height, right? So it's int width and int height, and then it should be basically width times height divided by 2. So we provide our own so now it's the override. So we need to implement we need to extends, triangle extends and shape. Okay, so that we are overriding this compute area. So we have a triangle class. Now, in order to support the creation of triangle, we just have to create the triangle factory class. Okay, so we are going to create new class and triangle factory class. And here, basically, I'm gonna again copy implementation from circle here and triangle factory and shape. Yeah, so I have to extend the abstracts shape abstraction factory class, and here I'm going to create triangle should have a height and width, right? So I'm going to say 7.0 and 8.0, and I have to go to triangle to have constructor method that receive height and the width. So let's actually create a constructor method. Select source and select constructor using fields and width and height. Now we have a constructor method that receive height and width. Okay. All right. So now if I want to create the triangle, basically, I am selecting triangle factory class. So here I'm just using the simple way of creating for demo purpose. Okay. So here triangle factory, and since I'm using shape factory abstraction type, it should work right away, and then I should be able to decall it. Okay, so now if I run it, yeah, so basically it should actually create a triangle, the object through the triangle factory class. Okay, now we are going to look into abstract factory pattern. So this is probably the most difficult, one of the difficult patterns to understand. Okay, so let's move forward. So abstract factory pattern provides abstract factory interface for creating families of related products without specifying their concrete classes. And it provides a way to encapsulate a group of individual factories. Now you might want to say, what the hell am I talking about? Okay, I understand that. I'm going to actually use an example code and we'll actually get back to this slide again. Okay. I'm going to just finish up by reading these two bullets, and we're going to actually move on to the participants and then lab code, and we'll get back to this again. Okay? So by writing code that uses abstract factory interface, we decouple our code from actual factory that create the products. And because the code is decoupled from actual products, we can substitute different factories to get different flavors. So in this case, as you're going to see later on, yeah, so I'm going to get back these aspects after we've done the lab work. Okay. So these are the participants. We have abstract factory, we have a concrete factory, abstract product, and we have a client. So, it might look a little bit same to the factory method pattern, but it is a bit different. Okay. So without actually going further on those slides, let's do the lab exercise, and I'm going to get back to those bullet points again. Okay. All right, so the one that we are going to take a look at is DP creation, abstract factory, compute shop after. Yeah, so this is the one that I don't have any before code, so we're going to take a look at the after code. Okay, what we want to do is, we'd like to actually create an application where we like to create a machine like a PC that contains expensive components such as hard disk drive and the processor and monitor and things like that. And it also creates, so that is basically a high budget machine, and then we have a low budget machine. So let's actually take a look at the abstract factory class. So this is the essence of abstract factory pattern. In abstract factory pattern, you define an interface. In this case, iMachine factory. So it could be iMachine or iPC factory, and this is in fact the abstract factory. Abstract factory contains a set of creator method. So here I created a processor, I created a hard disk drive, and I create the monitor. Now the type of this guy, each of those is supposed to be abstract as well. So here this is iProcessor abstract product, and iHard disk abstract product, and this is iMonitor abstract product. Okay. Now this interface will be implement, and now you can see these are the related products, right? So product, the processor, hard disk drive, and monitor, those are related, a family of products. Okay, so we want to actually create this one as a family of products. Okay, now so this is the essence. As I said, this is in fact what is called the abstract factory. So this abstract factory need to be implemented by some class. So I have in this case high budget machine concrete factory. So this is a class that implement this iMachine factory abstract factory, providing concrete implementation of those methods. So here I'm creating a processor, hard disk drive, and monitor. Okay, so here create processor method will will create expensive processor object and expensive hard disk drive and high resolution monitor. So this is in fact a factory class, concrete factory class, implementing this iMachine factory interface. Now again, we are creating a family of products. So that is in fact the difference from factory method pattern. In factory method pattern, we are just dealing with a single product. Here we are dealing with a family of product. Now I'm going to actually have another concrete factory class called low budget machine concrete factory class, in which is going to create a cheap processor, cheap hard disk drive, and low resolution monitor. Okay. So we have this concrete factory class implementing this the abstract factory class. Again, it's creating a family of related products, right? Okay. And so then basically all we have an iProduct, the iProcessor abstract product is basically an interface that contains some method. Okay, and then we have the actual implementation class of this iProcessor abstract product. So one of those is going to be the expensive processor. So expensive processor is basically the type of iProcessor abstract product. So in this case, it has implemented the perform operation method. Operation will perform quickly. So if you run this code, what is going on for me? All right, so let me just, I don't know why it's actually all doing these things for me. Yeah, something is not right. Let me just restart the Ellipse. Okay, so I am going to give you guys 30 minutes to do the abstract factory pattern. Question? Unless you have questions, I'll give you 30 minutes. So right now it's 2:30 and we will be back at 3 o'clock. And of course I'm around, so feel free to ask any questions you have. We have covered 3 different types of factory pattern. Simple factory is very simple. It's just the encapsulation of object creation logic into another class. Factory method pattern is basically we have abstract class that contains abstract method, abstract factory method that will be implemented by other concrete factory classes, that is factory method. And abstract factory pattern, you basically have abstract factory interface in which related products could be created. Okay, so hopefully you guys see the differences among these 3 different styles of the factory pattern. Okay, all right, so let's move forward. Now we are going to talk about 2 more creational pattern. Singleton pattern is quite frequently used. So let's move on to the singleton pattern. So in singleton pattern, there is only a single instance for a class. Okay? And the pattern also provides a global point of access to it. When to use it? When you need to have centralized management of a single resource. So examples are window manager. In a single application, single system, there should be a single instance of window manager. And then you need to have an access to that window manager. It could be a good candidate to build it as a singleton. File system object. So there could be a single instance of file system object that could be accessible, okay, in a global fashion. Okay, so in singleton pattern, you basically create a singleton class, and that's pretty much it. And client can use that singleton class to create a singleton object. It does have a private constructor, so it prevents other objects from creating new object using new keyword. Okay, so it is impossible to create new to create a singleton object by using a new keyword. It does have a static method that returns a single instance. Okay? All right, so singleton pattern. So this is one of the easy design patterns. So let's take a look at the singleton pattern here. I have a single example, singleton counter after. So in this case, we have singleton class. Singleton class. The first thing is that the constructor method is set to private. So you cannot create singleton class using a new keyword. If you try to create it, then it's going to be a compile error. So if I try to create, for example, singleton x new singleton, it will not be allowed. It will say the constructor singleton is not visible. Okay, so that cannot be done. All right, so the reason is because we set the constructor with a private, okay, modifier, and then internally we are going to create a single instance of it. So here we are using new singleton, and then we assign it into instance variable, and we're going to actually set it as a static type. Okay? And then we are going to provide a method that other objects can call to get this instance. So we are going to provide get instance method, and this is the one that actually returns this instance that we have created. Okay? And then we, in this case, in this example, we have a counter. So every time add number to counter is called by any object, we are going to increment the counter. Anytime any object calls a subtract number on the singleton object, we are going to subtract it. So that's basically what we do here. And then you have a get counter method. Okay. So in the client code, this is how you're going to get a singleton object instance. You call get instance method of singleton class, and then you get the singleton object. So here we are going to add a number to counter. So we're going to add 5. Okay, so 5 will be added to singleton object, and then we are going to subtract 2. So it should be 3. So when we display the number, it should be 3. Okay, and then we are going to actually have we are going to call get instance again, and we actually get the singleton object instance, and this should be in fact the same object of this guy, right? So here, if I add a number, okay, using singleton 2 variable, it should actually still point the same singleton object. So it should actually add 1, so the number should be 4. So, excuse me. So if I run this code, yeah, should actually return 4 at the end. Okay, and so this one 5, and then the subtract 2. And then it should return 3, and then this one should return 4. And here you should be able to actually compare, in fact, singleton whether they are in fact the same object, singleton 2 and true. Well, let's actually say true or that one. Yeah. Let's see. True or false. Okay, and then we're gonna just display this guy. Well, I should be able to just do this. This out, and let's see whether this returns true or not. Okay, so it returns true. So they are pointing to a same object instance. Okay, all right. So it's pretty straightforward. So let's do the homework. So here your homework is creating singleton time teller. So basically I want you to create time teller singleton object and then call tell time, and it should display current date and time like this. Okay, so pretty straightforward. Okay, so I'll give you about 10 minutes to do this. You're going to run the sample singleton counter project and get the sense of how things work, and then you're going to do this homework. So I'll give you either between 10 to 15 minutes depending on how you guys are doing. Next pattern is the builder pattern, and builder pattern is kind of useful. So what is it? It separates the construction of a complex object from its representation so that the same construction process can create different representations. So the alternative to this is that you have a set of constructor methods, and those are pretty static. I mean, those things need to be done at the compile time. What you want to do is we want to be able to build an object, different representation of the object, depending on business condition during runtime. Okay, and I'm going to explain what that means in a few minutes. Allow final control over construction process. Unlike other creational patterns that construct products in one shot, builder pattern construct a product step by step under the control of a director. Okay? Again, if you don't understand what I'm talking about on this slide, don't worry about it. What we are going to do, as we have done, is to take a look at the lab, the exercises, and then we'll come back to this definition and the participant slide, and you'll have a better understanding. When to use it? Use it to simplify object creation when object needs to be created with complex set of initial arguments. So instead of actually having constructor method with a very long list of arguments, you could actually use a builder pattern, which is actually providing like a chaining method, which is a lot simpler to understand. Use it when object creation needs to be done flexibly. So sometimes you want to create an object that contains certain set of the values, and so I'm going to actually explain these things in a bit more detail after the lab. Okay, participants. So we have abstract builder, abstract interface for creating parts of the product. Then we have a concrete builder, which implement abstract builder. And the one key aspect of this concrete builder is keep track of the representation it creates, meaning whatever that has been created up to that point will be maintained in concrete builder. Then we have what is called the director. This is the one that constructs that complex object using abstract builder interface, and a product represent complex object that is being built. Okay, so as I said, if you don't understand what I said on this slide and previous slide, don't worry about it. You can actually do the lab and you'll have a better understanding. Okay, so I have several examples of builder pattern. So let's try the simplest possible builder pattern. So we are trying to build a car. So without using builder pattern, this is what you probably have to do. So I have a car class that has very complex set of the properties. So we have only 5, but let's assume that are in fact 20. Then you might in fact have a constructor method that receives those 20 property values as initial arguments. Okay, and then we have a setter method and getter method basically. Okay, and then we are going to create a client. We are going to create the car object by using new keyword. So this is an example in which we are not using builder pattern. So we are going to refactor this guy to use a builder pattern. So let's see the end result. I'd like to actually show you step by step to do it, but for the sake of timing, I'm going to just show the end result. So we have a car class, which is the same, okay? And then we have a car builder class. Okay, now let me actually show you the end results. Once you got the car builder class, the client should be able to call this method like this. So once you got the car builder object, you should be able to create a new car. So it doesn't contain any initial values. And then basically you can call add engine, add tires, add exhaust, add door, and then finally you can call get car method. Okay, so builder pattern, this builder class should have new car method for creating initial blank car object. Then we have a set of setter methods. Okay, add engine, add tires, add exhaust, and things like that. Now, you can see we are using this chaining method, right? So each of these objects should return, in fact, car builder object. So because it's returning car builder object, we can just keep calling methods in the car builder. And at the end, you can call get car method of the builder. Okay? So this is a lot simpler than using the constructor method. Okay? This is another example. So we can say, we can say car builder, then we can just call new car method. Again, is initializing car object with no value set, and then again we can call various set of methods. Now you can see we have in this case added 4 properties: engine, tire, exhaust, and door. But in some cases I want to add a sunroof, so I can call sunroof, and this guy doesn't have a sunroof. Okay, so it doesn't call sunroof, but here I want to call sunroof. Okay, and eventually I can call get car method to get the car object. In some cases, maybe you need to have this engine to be added first before tires, because tire somehow has a dependency on engine property or something like that. Okay, so in this case, basically you can control the order of how things is done. Okay, so what you can do is, so when I say, go back here, use it when object creation needs to be done flexibly. That's what I meant. Here I can select the set of properties. I don't have to actually add these two. In that case, I can just comment these two lines out. So in this case, I'm creating a new car just with the engine and tires and sunroof. Okay, this is perfectly fine. And also, I could actually order I could actually call add tires before add engine in case that's actually more desirable things to do. Again, that is flexibility. Okay. So when to use it? Use it to simplify object creation. This is a lot simpler than creating a new method with a bunch of initial arguments, right? So this is a lot more readable than using the new keyword. So use it to simplify object creation when object needs to be created with complex set of initial arguments. Okay. Okay, so let's take a look at the car builder class. So car builder class, it does have in fact the final object type instance, car, and it's private. Okay, and first thing it does in fact is creating brand new car. The car object. So here it's going to create a car object and then set into a car internal field. And then you can see all these methods are returning car builder object, right? This is important. Every method except the get car, that final method that you're going to call, except get car, every method in fact returns car builder. Basically all it does is just returning this. Okay, so car builder, in this case add engine, is basically calling a setter method and then return this. So if you actually go back here, the builder pattern, so here I said the concrete builder defines and keeps track of the representation it creates. What it means is, if you take a look at the client code, when you call add tires, basically at that point, car builder object maintain a car instance whose tire has been added. Okay, and then when you call add engine, then add engine property will be set. Okay, so whenever each method, and the result of calling each method is actually creation. The car object whose state has been changed. Okay, so that's what I meant over here. So concrete builder in this case is the car builder. Okay, in this case we are not actually using the abstract car builder. We just use the concrete class, okay, because that's the reason I say simple. So here keeps track of the representation it creates. Yeah, that's what I meant by the car builder object maintain the state of the car object. It's maintain the state of the car object. Okay. All right, and so basically two important methods here is creating a brand new car object, but it returns a car builder. It's just setting this internal variable which maintaining the state of the car object. And finally, there is a get car method that actually returns this car object that has been constructed up to that point. So pretty straightforward. So this is the simplistic case. Now let's see whether we have a director. So you can think of director is like an intermediate class. So in this case, we have car builder, that is the abstract class. Okay, so this abstract class has again the same car instance and get car method and create builder method, but in some cases we want to create a different car, right? So we want to create the abstract method for engine, tires, and exhaust. Okay, so so fancy car builder will actually provide a fancy version of the engine, fancy version of the tires, fancy version of exhaust okay, system. So you can see these are basically fancy version of creating just entire engine and add those things to the car. And then we have a fast car builder. Fast car builder is again extending car builder, and this is actually adding fast version of the engine, fast version of tires, fast version of exhaust system. And then we have the director. So this is intermediary code in which car builder is injected. Okay, so it's injected through a constructor, and then it has a build car method. Okay, and then it's going to use a car builder object. It gets the car builder. Okay, it's going to create the basically car instance, and then it calls the set engine, set tires, set exhaust, and then finally it's going to get the car. Okay, and the client code is basically using that the car factory intermediary class, which is basically playing role of the director. Okay, so here we are selecting the fast car builder during runtime. Okay, so whenever you see this kind of code, this doesn't mean that this code has to use this concrete class. In general, this should be able to be actually selected during runtime as a command line argument. Okay, so we have fast car builder and the fancy car builder, and we can just build those cars. So one is fast car, the other one is a fancy car. So if I run this guy, run as Java application, and we should actually build the fast car and the fancy car. So this one we actually not differentiating the sunroof, the different cars here. This is the one that actually, this is build car simple after. This is an example whether we actually created the car with the sunroof, right? Okay. So here, this car, fast car, doesn't have a sunroof, but this guy has a sunroof, but it doesn't have the other two parts because I comment this guy out, right? Okay, so by using builder pattern, you can create an object in a lot more flexible fashion. Okay, all right. So if you take a look at the general, so that is a builder general. Oh, this is the sandwich. So sandwich is again very commonly used example. So sandwich is the one that you can add a bunch of the items like a vegetable and the meat and things like that. So here, let's take a look at this guy. Okay, so this is the actual example of using director. So we have order taker director. This is the one that actually is used by the client. Client will use this order taker. So imagine that is in fact the order taker in a restaurant, and that person is playing the role of director. So the director knows which sandwich builder it wants to use. So we have sandwich builder, abstract builder field, okay? And this will be set with a concrete the builder object, okay? And then it does call the build sandwich, and it's calling new sandwich. And then you are going to select bread, add vegetable, add meat, and add cheese. And then we have at the end get sandwich method that actually returns sandwich by calling get sandwich method. Okay, so this order taker is sort of the intermediary class that knows how to invoke a builder object. So if you take a look at a client code here, so here during runtime it could actually select beef sandwich builder. So if you take a look at the beef sandwich builder, it's basically using different implementation of select bread, add vegetable, add meat, and add cheese. Okay? So these are different business logic. Okay? And the final object is, of course, a sandwich, which is actually from the sandwich builder, abstract builder class. So if you see here, we have a sandwich product. Okay? And we have a veggie, and again, it works pretty much the same. So it's, in this case, it's selecting veggie, lettuce. In this case, there is no meat and no cheese and things like that. So in the client, basically, you are going to select a particular builder object during runtime. Again, this selection of builder could be done during runtime, okay? Again, as command line argument, Okay, so once a builder object is selected, basically it's going to, in this case, we are using order taker as an intermediate class. So it will call builder sandwich, and builder sandwich is calling those methods, new sandwich, select bread, and add vegetable, add meat, and things like that. And then it is going to call get sandwich method finally, and which will call sandwich builder, get sandwich, and returns sandwich product, which is an abstraction. And that abstraction will be used to, we'll just display it at this point. Okay, so sandwich builder sandwich is again quite frequently used example for builder pattern. Okay, so in some cases, for veggie, yeah. So if you think about it, for beef, in this case, yeah. So so I'm thinking about veggie builder. So in this case, so this is kind of no operation, no meat and no cheese. I'm thinking how we can optimize the code so that veggie sandwich builder doesn't really have to deal with these things. So in sandwich order taker builder, so what we could do is, here we could in fact have instead of calling the add meat all the time or add cheese, we could actually differentiate depending on whether the veggie is built or the beef sandwich is built. That's something that could be optimized. Okay. All right, so that is the sandwich builder. Let's actually see the general version of it. So here I'm actually trying to use the participant terminology. So here we have abstract product builder, and it contains the set of it does include, it has a reference to product, okay, and it is a brand new create production here. Then we have a set of abstract method, okay. And then we have a concrete product builder. So this is a veggie, and this is the beef sandwich builder, so to speak. Then we have a director, okay, which is an intermediate class that is being invoked by the client, that is being used by the client. So this one should have a reference to abstract product builder. That abstract product builder will be set through the constructor methods. This is a constructor-based dependency injection. And then we have a build product and get product, okay? And the UML class should look like this. So we have abstract product builder, which will be implemented by concrete product builder, and the director has a reference to abstract product builder, and this abstract product builder will actually create a product. Okay. All right, so that is a builder pattern. So let's do the homework. So build a pattern. Here we like to build a vehicle. Okay, so if you take a look at the client code, we like to build either automobile or bike, okay, using builder pattern. Okay, so here we are going to have here we are going to create the bike using a bike builder. Here we are creating automobile via automatic builder. Okay, so the steps you're going to take is create vehicle builder. That is an abstract class which contains set engine, set tires, set exhaust abstract method. Okay, and then automobile builder and bike builder, those are concrete builder classes. Implementing abstract method of this vehicle builder. And then you also need to create a vehicle factory class, which is playing the role of a director, to which vehicle builder object will get injected through a constructor. And then it has a build vehicle method. Okay, so when you run the code, it should look like some. So I have the end result. If I run this guy, run as Java application, it should actually run like a bike. Has engine, added bike tires, added bike exhaust. Okay. Yeah, so initially as a bike, and then engine added, and tire added. Oh, okay. So it looks like this. Each of this one is actually, yeah. This one is from one builder method. This is another method. This is another method. Okay, and this is for automobile. Okay, so I am going to give you guys. Let's see. This is the 340. I will give you. Let's see how many patterns we have. A builder, prototype, and object. Yeah. Okay. So I think you're doing well. Yeah. So I'll give you guys about the 15 minutes to do this builder pattern. 15 or 20 minutes. Okay, that should be okay. So the end result, this is the end result. So basically we have a vehicle builder, which is the abstract type. The end result, it basically is creating a vehicle. And so it does have get vehicle method and create vehicle method. Okay. And then we have an abstract method, which are implemented differently depending on whether you are building a bike or whether you're using automobile. Okay. And then we have a vehicle factory, which is the director class, which is injected with the vehicle builder, and is basically, you know, building the vehicles using builder object. Okay. All right. Now Prakash Sharma wants to see how we can create SOAP message or JSON message for that matter using builder pattern. So let's actually try that. So I'm going to just copy this project, and I'm going to say EP creation builder SOAP message or something like that. Okay, so I have this project here. Okay. So in general, I might actually create from scratch, but for the sake of the saving time, I'm going to just use the existing structure. So first of all, we like to create abstract builder class. So this, instead of vehicle builder, we're going to actually change it to message builder. So I'm going to actually rename it as message builder. This is going to be abstract class. Okay. Because we want to create the SOAP message and JSON message using different builder. So this is the abstract class, and here we are going to create, instead of vehicle, we want to create a message. Okay, so for vehicle, let's change this guy to change the name of vehicle to message. And message contains, so I'm going to change, instead of engine, I'm going to say header, and maybe it has body, and maybe it has the, footer. So I'm going to just change it to footer. Okay. So every message should have header, body, and footer, and of course, SOAP has its own version of whatever field. So this is the message. Now I am going to create a SOAP message. So in this case, let's actually create the. Okay. So this is a message, and we could certainly create a SOAP message. But for now, let's focus on message builder. So we are going to create a SOAP message by implementing, this is message builder abstract class. Okay, so I'm going to choose one of these things and just change automobile. I'm going to change this guy to SOAP message builder. SOAP message builder, and this one should. The SOAP message builder should extend message builder. So in this case, instead of set engine, we are going to add header. Add header. You know what? I'm going to change it to message header, message builder. Message builder. So yeah, so I'm going to just change So here I'm going to say add header, and this one add body, and this one is add footer, something like that. Okay, so oops. Add footer. Okay, so now SOAP message builder should have extend this guy. So it does have all these things, and message builder, yeah, let's actually save the changes. And okay, so message builder has this abstract method, add header, add body boot, yep, okay. And this one is yeah, so we like to change this guy as a message as well instead of vehicle. So we'll say message, we change it, and instead of get vehicle, we are going to say get message, and new message. Yeah, so we have create new vehicle. So this one we need to change it to create new message. Okay, so create new message. Okay, so this is actually creating a message object and just initialize it with blank. Okay, and then you have get message that returns it. Then we have abstract method. Okay, now let's take a look at the SOAP message builder, which is extending this message builder. So let me see what it doesn't like. SOAP message builder must implement inherited. Oh, okay, so it looks like it. Oh, yeah. So this is somehow add tires. It's not set to add body. Okay. All right. So everything is good. So we're yeah. So header edit, body edit, and footer edit. Okay. All right. So that is a SOAP message builder, and then this one we're gonna just delete this guy. And if you want to create different message type like a JSON builder, basically you have to create a JSON builder object. So I'm gonna just use the SOAP message builder, and we are going to copy, and here we are going to say JSON message builder. Okay. And so JSON message builder is actually creating, yeah, so we could just say JSON to make sure that this is a JSON specific implementation. Okay, all right, and now yes, so this is the director. So again, you can think of director as like intermediary class. Okay, so I'm going to change it to this guy is message order taker or something like that. Message order taker, something like that. Okay, and so this is the one that is actually being called by the client. Okay, so it does have message builder. This is an abstraction, so it could be either injected with the SOAP message builder or JSON message builder. And then it would create first create new message, right? And then it will add header, and then it will add body, okay? And finally, it should actually call get message, like this, okay? So now client will use this message order taker. And so in this case, instead of bike builder, we are going to actually use new SOAP message builder. SOAP message builder. Again, the selection of a particular builder could be done during runtime, right? So so instead of bike builder, I'm going to just say message builder. Okay. So yeah, so in this case I'm creating both, so in this case I could actually use a JSON message builder. so here we are creating SOAP message, and here we are creating JSON message. Okay, so let's actually run this guy. Yeah, so it's basically header, footer, and then here we have a JSON header, JSON body, JSON footer, and things like that, right? Now, nice thing about this builder pattern is if I want to create, another type like a JSON message or a SOAP message, or let's say I want to create the binary message or something like that. Basically you have to create a binary message builder class, okay? And that will be injected into message order taker, and then it will actually create the binary message for you. So again, it is following open close principle, in which in order to support different message type, no existing code need to be changed, right? The only thing you have to do is creating the binary message builder, and you also have to create the message object or binary message. In this case, I'm just using the message class, right? But this could be abstracted as well, right? So it could be abstract class, and then we could create the SOAP message. So here we create SOAP message, and this SOAP message is going to extends message, and you could have SOAP specific things, private string, so tag or something like that, okay? So in this case, when the message is built, so instead of actually creating the SOAP message, in this case, it could be actually inject with a particular message as well, right? So here, this one, create a message, and here we are creating, so message is basically in this case, abstract class. I create an abstract class, okay? For the sake of this exercise, instead of message class, we can just overwrite that's not good. So in this case, if I want to support, let's actually see an example where we actually used different vehicle avatar. So if you think this is we are basically creating the vehicle. This is the class type, right? And then we have so that's not the example I was looking for. If I want to create a different type of the product, then we could so vehicle builder. So if you want to actually have a different vehicle, so in this case, then we could actually have this vehicle to be injected. Okay, so when it's actually creating this guy, we could actually have it to be created with either with the so in this case, create vehicle. So the thing you can do is what I can do is I am going to construct a method for this guy. So here I can see the vector, source, and constructor from fields and vehicle, and so this vehicle builder object will be created using concrete, the vehicle object, okay, and then so in this case, create vehicle will be you know what? It's just kind of messing things up, because in the create new vehicle, we are basically creating a fresh object, so and it's not gonna help. So if you want to create a different so if I want to actually create, the different type of object, like a vehicle, in this case we have, let's see, we have automobile builder, and in this case, oh, yeah, I was actually confusing you. Sorry about that. The way that we are going to actually create a different project is using different builder. And basically, this is how we are actually creating. This is the different implementation of that object, okay? So in this case, the actual implementation of this guy is setting vehicle object with the automobile specific things, okay? So we don't really need any other type like automobile or bike in this case. And what gets generated is in fact the vehicle object that contains different implementation for automobile and bike. Okay. All right. So hopefully that is kind of clear to you guys. Okay. Sorry for the confusion that I caused. Okay. So let's actually move forward. We have two patterns left. One is prototype pattern. The other one is the object pool pattern. So prototype pattern allows you to create a new object by cloning. So you want to use a prototype pattern when you when the creating new object is pretty expensive. So creating new object from scratch is a lot more expensive in many cases rather than just cloning. Right? So that's basically what prototype is all about. So here, prototype interface, it declares an interface cloning itself, and concrete prototype implements the operation for cloning itself, and then you have a client. Okay. Again, let's actually take a look at an example of this. Okay, so we have cloning. A prototype here. Okay, so we have a simple case, the before case. So we have a concrete object. So in this case, we have a concrete object in the client. In order to create this concrete object, I'm just using new keyword and assume this creation of this concrete object is pretty expensive. Okay, that's where we can actually use the cloning. So here we created two objects. I mean, should it work as expected? Nothing really. Oh, we're just creating. We don't even have to display anything. So that's the reason it doesn't show anything. So now if you take a look at the after, where you're using prototype, okay? So we have iPrototype, and this is using the clonable. This clonable is the class from JDK, okay? And basically it is this is an interface, okay? And it does have a clone method, okay? So we have iPrototype extending clonable interface, okay? I believe clonable is basically just a marked interface. So this is the JDK code, it's a marked interface, okay? Then we have a concrete prototype class, which implements this iPrototype, okay? And here we are basically using cloning. So here what we do is that, if so here we have result iPrototype, and we clone it, okay? And then return the result, okay? And then, so that is concrete prototype. Yeah, so this is a very simple way of creating an object by cloning. So using cloning when cloning object is more efficient and faster than creating a fresh one, right? And client is basically just, using that clone object. So here we are using concrete prototype, and we got the original object. And then creating a new object by cloning could be more efficient and in speed. So we basically clone it, and then we have object 2. So now actually try to see whether object 1 and object 2 are the same. And we also use the equals, and then you also checked. We also get the names of those. Okay? So let's actually run this guy. Run as Java application. Okay, so original object is Sang Shin as a property, and clone object Sang Shin, and object 1 and object 2, they are not pointing to the same object. Okay, they are completely different object as expected, but it basically gets created. The second object gets created by just cloning the first object, and it's a lot more efficient. Okay, and so this one should return false. And of course, they should not return, equals, equals, unless you override the semantical behavior of equals. This is the same thing as this guy. So this should return false as well, okay? But when I try to get the name of both, they should be the same. So, the name of this guy is a Sang Shin, both of them, okay? All right. Okay, so cloning is basically constructing an object by clone. Prototype pattern basically clones an object, and that is considered a lot more efficient. That's all. Okay, so your homework is basically where is the prototype? Okay, so here, client. So create a circle object by cloning, manage the collection of them in a map. Okay, so basically you're going to create the several circle object, and you actually save it into into a map. Okay, since we don't have enough time, I'm gonna just show you the end result. So here I am going to run as Java application and DP, and the original object, clone object, true and false. So if you take a look at this guy, we have prototype manager. This is basically a map of the object, okay? Shape object. So we have object and shape, and we have add prototype and clone prototype. So when we add prototype, we are adding to the map, okay? And if we find the object we want, we can just clone it. Okay, so in this case, I get the object, and then I just want to clone it. Okay, which is supposed to be a lot more efficient. Okay, so in the client side, so create a two original object, and then create another object by cloning, and we just basically display those things. So cloning could be useful. Suppose if you have to create 10,000 object, okay, that has a pretty similar the state, that has the same state, so to speak. Or even if they don't have the same state, you can create first, and then you can actually add the state or set the state and things like that. So by cloning, it's going to be a lot more efficient. It's going to be faster than constructing by using new keyword. Okay, so that is a prototype. So let me just move on to the last creational pattern, object pool pattern. So basically, object pool pattern is you create a set of objects in a pool, and then basically you are going to reuse them, or once you're done the usage of it, you are going to just return to the pool. And examples of object pool pattern includes database connection pool and thread pool. Okay. All right, so let's take a look at exercise 7. So exercise 7, so here we have object pool general after. So basically in this case, we have object pool. We have a code that actually handles the creation of object pool. It does support locked resources hash table and unlocked resources hash table. We also have expiration time. So we basically initialize the locked resources and unlocked resources. Okay, nothing has been created yet at this point, and then we have an abstract method. So depending on particular resource, okay, we want that resource to be created differently. So we want to have an abstract method called the create resource. And then we have a validate, to see whether that resource is in fact valid or not. And we can also have expire. So depending on resource, object, these three behavior could be actually different. Okay. Now, in terms of checking out resource, check resource, and release resource, they are the same. It's basically using, this generic resource pool. Okay. So, it's basically checking whether when a user wants to check out a resource, and it's actually synchronized, okay? First of all, we see whether unlocked resource is greater than 0. That means there is in fact the available resource, okay? If not, then in that case, we're going to actually select the available resource and return, okay? So that's basically when this is being returned. However, if there is no available resource, then we are going to create resource. So this create resource is an abstract method, and that again will be implemented differently depending on a resource. And then we are going to add that resource into locked resource because that is locked. The resource is being used until it's released, okay? And then return. If there are in fact available resources, we are gonna actually find. So we're gonna in the while loop to find available resource, okay? So here we are going to use iterator pattern, get element, and then we check whether it has expiration time or not. If it is not expired, then if it is in fact expired, then we are going to actually remove it, and then we are going to actually call expire. Again, the concept of expire could be different depending on the resource. Data connection resource is different from thread resource depending on what expire means. And the validate is also the same. It is the same deal with the expire. So the different resources will have a different behavior in terms of validate. Okay. So if validate returns true, then we are going to assign. Basically we are going to remove it from unlocked resources, and then we're going to move it to locked resources, and then return. Okay. So this is the generic logic that could be used for any resources. And the same thing for release resource. So here we just remove it from locked resource, and then we just put the unlocked. We're going to put it unlocked resources, and we also set the time of it. Now each different resource object, I'm going to actually call it my resource, will provide a different implementation of my resource. I want to show you my resource pool here. So my resource pool will have a different implementation for create resource and validate resource and expire resource. Okay, so depending on what resource type you're talking about, these three methods will be implemented differently. Okay, so you could have a my resource pool, and you could have a my resource one pool, things like that. They will have a different the implementation of this. Okay. And so, I have my resource, just have a resource ID, okay? So if you want to support the different resources, then you could have a my resource one and my resource one pool.java, and the client code, basically create a my resource pool object, and then it's going to just call checkout resource and checkout resource. So in this case, we check out two resources. And then you are going to use their resources, and then we are going to release the resource. Okay? All right, so, basically when I run this code, yeah, I'm using resource 1 and resource 2. That's basically coming from here. Okay? So again, this is the, the client code. So, you could actually select particular resource pool object during runtime, okay? Maybe again, command line argument. And again, this code does not need to be in fact changed if you actually ask those things out. So right now I'm actually using concrete class, right? So in this case, I'm supposed to actually use, in this case, I have to use like object pool. So that's, yeah, it should be object pool, okay? And new resource pool, my resource pool is the extends object pool with object my resource. Oh, okay. So it should be my resource pool. Oh, okay. That's good. Okay. Now I am going to use checkout resource. Why it doesn't like it? The message cannot convert to. Oh, okay. So in this case, because I'm actually using the object pool, I have to actually in this case cast with my resource. And yeah, so what I was actually saying is that this line of code could be abstracted out. This particular pool could be actually selected during runtime and then this code should be working okay. But when you actually return, so in this case, yeah, so I should actually have, in this case, I should have another abstraction like a resource. So I could have the new and so here, yeah, so maybe I should say maybe, you know, like a resource. So I'm going to create maybe resource object, resource class, resource. And here my resource is going to be extends resource. And in the client code, I should now say resource and resource. Okay. And then here, do something with, you know, so I could actually have my resource, I could actually, my resource, these things could be, move up to a resource. So I can say refactor move up to just, yeah, just move all. Okay, so now my resource pool, in this case, let's see, my resource pool object pool resource, and type my resource pool not implemented. Oh, yeah, looks like I need to validate. Yeah, okay. My resource is resource, and then resource is resource ID, do something with, and my resource is, okay, so my resource pool. Add unimplemented method. Okay, so validate, and then this one is multiple methods. The return type isn't compatible object pool. Okay, so resource. Yeah, mine doesn't like that. Return type is incompatible with object pool my resource. Oh, okay, so object pool is create. Oh, this one. Create resource is returning type T. So let's see. T. Oh, yeah, this one. Yeah, so this one should be, yeah, okay. So, yeah, this one should be my resource. Because I'm actually dealing with my resource, so I should be able to actually use my resource, yeah. Okay, so Boolean, and same thing with the my resource, is, and resource ID of duplication method. Validate. Oh, yeah, we have a duplication method here. Okay. And expire resource. Again, this one should be my resource like that. Okay. Oh, we have a duplicate method. Okay. Okay, so it's a long process, but that should work fine. Okay. All right, so you know, if I run this guy, it should probably work. Okay, so right now it's 4:30, so let me just stop